Hi everyone, this is another video on how to analyze potential divider. We started off by first using a variable resistor, and then in another video we used the light dependent resistor, and now over here we are using a thermistor. Now the behavior of thermistor is such that when the temperature increases, the resistance of the thermistor decreases, and when the temperature decreases, the resistance of the thermistor increases. And for this, we are going to analyze how the change in temperature affects the potential difference across V1 and V2. Now, this is very suitable for building a fire alarm. One example is a fire alarm, right? Very dependent on temperature. Another possible example is oven also. All right, design an oven to stop heating up the food once it hit a certain temperature. Now, let's continue. So what we have here in the diagram is a thermistor that's connected in series with a fixed resistor. The fixed resistor is R1 and the thermistor, we let it be R2. And we let the potential difference across R1 be V1 and the potential difference across R2 be V2. And the EMF of the battery will be V. And the current supplied by the circuit will be I. Like other questions, the current flowing through the circuit will always be constant. Now when we say always be constant, it doesn't mean that the value doesn't change. What it means is that the current flowing through R1 is equal to the current flowing through R2. That's all it means. And using this idea, we can form the equation I equals V1 over R1 and I equals V over R1 plus R2. Now, we're going to start off by analyzing what happens when temperature increases. So, to simplify things, I'll just call this hot and I'll call this cold. So when it's hot, R2 decreases. And we know V and R1 are constant. So from the equation, V1 over R1 equals V over R1 plus R2. When R2 decreases, that means R1 plus R2 also decreases. And since the denominator decreases, the fraction increases. Since V over R1 plus R2 increases, that means V1 over R1 also increases because they equal each other. And we know R1 is constant. Therefore, V1 has to increase. And we know V equals V1 plus V2. So, if V1 increase and V is a constant, that means V2 must decrease. Again, we analyze piece by piece, slow and steady, progressively. Hot, R2 decrease, and hence V1 increase and V2 decrease. How about under cold conditions? So when it's cold, your resistance of the thermistor increases. So your R2 increase. But we know your V and R1 are constant. And from the equation, V1 over R1 equals V over R1 plus R2. And since R2 increase, that means R1 plus R2 must increase because your R1 is constant. And since denominator increase, that means V over R1 plus R2 must decrease. And so that means V1 over R1 also decrease. And since R1 is constant, that means V1 decrease. And we know that V equals V1 plus V2. And since V is a constant, when V1 decrease, your V2 must increase. So you see here, when it's cold, R2 increase, V1 it decrease, V2 increase. I say again, analyze step by step. Okay, analyze step by step and eventually lead to the conclusion.